Greetings to you all students. Welcome to the Financial Computing course. My name is Louisa Mparuri and I will be your lecturer for this course. You get to know a bit about me as we progress with the lessons. This course is basically a combination of information technology and financial mathematics. It's a unique program that provides graduates with the requisite expertise for the development of a professional career in the profitable and intellectually exciting triangle formed by mathematics, IT, and finance. So basically, we're saying you may be a finance expert, but lacking those basic ICT skills that are needed in this world of technology. Or you can be someone good in ICTs or in mathematics, but lacking those skills that are required in finance. So as you do the entire course of financial engineering, you'll cover the mathematics required in finance, you'll cover the finance that is required by a financial engineer, and this course will now cement your knowledge in finance and mathematics together with the use of technology. So this blend is exactly what will give you a competitive edge as a financial engineer, where you are going to be able to come up with solutions to problems without the need to seek help, which in many cases needs another person who is, say, experienced in ICTs or experienced in mathematics, but now you have got all the skills in one. We'll also learn how to present data in a meaningful way, graphically, reflecting the behavior of certain phenomena. Learn to use tools like Excel, VBA, C programming, MATLAB, and there is a detailed course outline. With programming, we do not expect you to be experts or advanced programmers. We expect you to appreciate programming from a basic level, to be able to find faults or bugs within certain code where, say, in your day-to-day work, you've been using, say, an Excel spreadsheet that has got code that was done maybe 10 years ago. Business is changing every day. That code is no longer performing according to standards, but the person who did it maybe has long since left the organization. The person who did it maybe no longer exists. What do we do? Do you continue with that kind of a solution, or you need to be able to revisit it, look at what was done, how it was arrived at, and where do you need to adjust to suit the current settings? So those are basically the things that we'll be looking at in this course. Your appreciation of programming, you're doing basic programming, solving problems, financial problems, using both mathematics and your knowledge in finance together with ICTs. So the aim of this course, as on the screen, is to allow you to effectively apply technology in finance operations. The objectives being to maximize the usage of Excel package in data analysis, to be able to create useful functions in VBA, MATLAB, and C. You'll also be able to analyze data using the softwares learned. The course is structured as below, where you shall have 2 assignments. You shall have one individual assignment and one group assignment. The due dates will be presented to you during the live sessions. So we start looking at our first topic, which is data structures, algorithms, and flowchart. We need to be able to know what is the data type, what is a variable, different types of data types, some complex data structures such as arrays, and to some extent we will touch on some pointers. You need to be able to do your algorithms. Algorithms being step by step on how to achieve a particular tasks. And we need to be able to convert those algorithms into flowcharts for ease of understanding. By definition, a variable is a container of data. It stores data. An example of a variable could be my first name. The variable name is first name, and the value that it stores is Louisa. That's my first name. That value stored in a variable should have a data type. In my case, the data type for my first name is a string of characters. So for a variable to be used in any programming, it has to be declared, that it has to be known its name and its data type, and you also need to initialize the variable. Initialization is setting its value. For example, first name is Louisa. Another example is as shown on the screen, one's age. And the data type there is integer because it takes in all numbers. You could initialize that variable by setting one's age. In my case, I could set it to 40 because I am 40 in this particular year. Expressions are used to manipulate the values of a variable. You could think of a variable of salary initialized to $500 and the expression there could be, say, in December we add in one's bonus, which is 50% of the salary. So we could have salary equals 500 plus 0.5 times 500. So we have used an expression to manipulate the value of our variable, and the new value after manipulation is now $750, which is one salary plus their bonus of 50% of their salary. These things will make sense as you get onto programming. Have it at the back of your mind that a variable needs a name, it needs a data type, it needs to be declared, it needs to be initialized, and can be manipulated using expression. An array is yet another type of a variable, and pointers. An array stores a series of related variables. You could have an array of student marks in financial computing. So you would have the first student is Carl, we've got their mark. The second student, Raphael. The next student, Fundisani, etc. So as you keep on adding elements to an array, you are growing its size. You have to define, as you declare an array, its size. That is the number of elements that are going to be stored in that array. It also has the same concepts as we explained in variable. Declare, initialize, and you can manipulate it with expressions. Let's move on to algorithms. Algorithms are step-by-step procedures which defines a set of instructions to be executed in a certain order to get the desired output. They are ideally created without taking into consideration what type of a language one is going to use at programming. This is just a series of steps. For example, I could ask this one of you guys to say, how do you make a cup of tea? You will come up with an algorithm of making a cup of tea. I'll boil water, I'll pour my water into a cup, add a teaspoon of sugar, add a tea bag, I'll stir, I'll add some milk, then voila, I've got my cup of tea. So from that series of steps, I've articulated what I'm going to do to come up with a cup of tea. However, in business, we don't make cups of tea, but we solve business problems. So we are saying for any business problem that you want to solve, you need to come up with an algorithm which simplifies the process of arriving at the solution. Algorithms will help you in the case where you are working as a team on a project. One person could be the one who come up with the algorithm to solve a particular business case. One person could be in the programming team who will take that algorithm, convert it into a computer program, and solve the problem. So you have to understand how to break down a big problem into smaller steps and processes which are manageable using algorithms. There are different types of algorithms. We have search algorithms, sorting algorithms, inserting, updating, and deleting. As you will know, that data is always stored in an organized manner in computer systems. So you need algorithms to be able to do various operations. Let's say you are, for example, working in a bank and you want to be able to find your top 10 um, customers. You'd want to know those customers with the highest balances. So you could use a sort algorithm to sort your data according to the balance in descending order. So you can get your top 10 at the top of the list. You could also have an algorithm to search for all accounts that are in arrears. You will know that an account in arrear will be flagged in your particular system. So you will use that as a search criteria to come up with an algorithm and pull out the data that you need. You could also want to not necessarily delete but to suspend certain accounts for people who say have defaulted in the past 3 months. You could also use an algorithm to delete, which in case may be to archive, not necessarily throw away what data, as we know that data, we preserve it, we can archive it, and we can always go back to it, but it will not be accessible. So all these processes that we face in our day-to-day business are easily done by coming up first with simple, straightforward algorithms in plain English, which can be converted to computer programs, which will then produce the result. Algorithms have got certain properties, unambiguous. It should be clear. You cannot go about wondering on how you're going to solve the problem because that will also cause your program to be complicated and you may not arrive at any solution. Obviously, you need inputs to produce certain outputs. We talk of finiteness because an algorithm must terminate, it should come to an end after a particular number of steps when you find a solution to the problem. It cannot run indefinitely. And when you come up with your algorithms, they should be feasible within your available resources. With the inputs that you have, can you produce the intended outputs? If you come up with an algorithm which is not feasible, you will never solve the problem that you're trying to solve. And independency. We mentioned it earlier on that an algorithm should not be linked to a particular programming language, syntax, or code, as we shall see. It should be something written in plain language, such that any layman can understand the flow of events or steps that you are following to solve a problem. We have got that as standard notation for manipulating of expressions in algorithms. Just take note of that. Once you standardize your notation, it makes it easy for anyone to go across your algorithms from different organizations or project teams because you're using the standard notation. For example, there we say an algorithm is written in plain English, that is pseudocode. For example, in there, we want an algorithm to read two numbers and calculate their sum. So the pseudocode there will be the inputs to the algorithm is num1 and num2. Num1 and num2, remember they are what? Variables. We have decided to give them those short names. And then the output that's going to come there is the sum of the two numbers. How we do it is we'll receive the first number and then receive the second number, input the second number. Then the next step is we then add those numbers, num1 and num2, which is a process to produce an output, which is printing out the sum of the two numbers. So this algorithm is complete, it's finite after 5 steps, then it comes to an end. You can see that it's not ambiguous. You can see that it's not linked to any particular language. It's just in plain English. Anyone can really follow through and understand what it is all about. Besides writing your algorithms in plain language, there is a diagrammatic presentation of algorithms. So this comes in the form of a flowchart. The flowchart will help someone else to understand your algorithm in a better way. We all have got our different preferences. Some are visual, some are those who would expect to read. So you present your algorithm in pseudocode, plain language, and also in the form of a standard flowchart. A flowchart has got symbols that are used for each and every element of the algorithm. An oval would denote the beginning and the ending of the program or the algorithm. A parallelogram represents the inputs that are coming in. A rectangle is a process to be carried out in that algorithm. A diamond is a decision. If this condition is met, then do that. If this condition is not met, then do the other thing. We also have got a hybrid, which denotes an output operation. As we said, with algorithms, we have to start with your inputs to produce outputs via certain processes. So that is how it is used. And finally, every element or symbol used in there is joined by an arrow, which shows the direction of logic flow in the program. There is an example of an algorithm which has been presented in the form of a flowchart to calculate the area of a circle, which is pi r squared. It has got a symbol input, which is r, the radius of the circle, and the process there, represented by the rectangle, is r squared, which is pi r squared, which is 3.14 times r times r. You can see those multiplication symbols, which are representing the manipulation, the expressions as we spoke about earlier on. Then finally, we output our area of the triangle, area of the circle, sorry, and we end up. Thank you so much for taking time to go through this lesson. We'll stop here for now. Thank you.